So here we are continuing off our last video from project 121, and we're doing project number 122. And this one here is the Space War radio. There's what our circuit looks like. And there it is on the board. And this circuit we're using 3 volts. Our slide switch, our Space War IC, we have our touch button here, our D1 LED, but this time we're making use of our antenna and our variable capacitor. Essentially what we're making here is our own little AM radio transmitter. So what we're doing is we're taking the sounds made by a Space War IC and we're feeding them out through the antenna so we can pick them up on an AM radio. And our variable capacitor here will allow us to change the capacitance at this point, which in theory will let us tune the frequency that it can be received at on an AM radio. So let's turn the circuit on. See, we can tell that the circuit is working because our LED is flashing to the output of the Space War IC, but we can't hear anything because we don't have a speaker hooked up. So I've got a little Radio Shack AM/FM radio here. It's currently set to AM. For those who are curious what AM is, it's amplitude modulation. You can look that up if you want to learn more. Then we bring out the antenna here. Turn it on. See, we can hear the Space War IC, but we want to tune the radio frequency just so we can pick it up better. Okay, we kind of got it there. Now I'm going to adjust the variable capacitor to get a better tune on the radio. That's a pretty close signal right there. Let's see. We're picking up the AM signal being transmitted through the antenna on our little Radio Shack radio right here. And when I turn it off, there's just a static signal. It's not picking up anything. If I turn it back on, now our push button here is just to make different sound effects. So that is how project 122 works. So let's move on to project 123. So here we are with project number 123. It is the Lie Detector. And there's what our circuit looks like. And there it is on the board. In this circuit we've got our NPN and PNP transistors in use. Plus our antenna gets used again with a couple of other resistors. Our whistle chip, our 6-volt lamp, our speaker for providing audio, and our green LED for visual. And the way the lie detector works is it basically is supposed to mimic the way a lie detector works commercially, like when you use a polygraph. And so it measures the resistance across the human body, and one of the factors in determining if you're lying or not, especially with a commercial polygraph machine, is the sweat on your body, basically your sweat response. And anyway, we turn the circuit on and nothing happens, but if I touch these 2 points, see, our LED comes on and we get an audio signal out of the speaker. Now if I wet my fingers a little bit, simulating that I've been sweating a little bit, see, now it's higher, it's more rapid, and it's indicating that I must be sweating a little bit. Okay, now let me wet my fingers some more. See, now it's actually turned on the light. Yeah, it's going away. Basically what it simulates, let me go back and put that wire on here, like what we were just seeing. See, that simulates that I was really sweating, just like you recently saw, and the 6-volt lamp came on and the sound from the speaker stopped. This basically says that I must be lying because I'm really sweating again. What's happening is we're triggering our PNP transistor here to turn on our lamp, while the NPN here is working with the speaker and our LED. And so when we get enough current to go through here to turn on this PNP transistor, then the light will come on. And again, it's all triggered by how much current we can drive through there. And the thing is, when your hands get wet and you sweat, you actually reduce the amount of resistance that you have, so it makes it a lot easier for it to pass current through there and trigger that PNP transistor. So that is how project number 123 works. So let's move on to project 124. So here we are with project 124. It is the NPN Amplifier. Here's what our circuit looks like. And there it is on the board. And essentially this demonstrates the amplification of the NPN transistor. So as you can see, we have our variable resistor, a 100 ohm R1 resistor going in, our D2 green LED, again our NPN transistor, and our 6-volt lamp. And again, the whole thing works on 6 volts. Now right now, with the slide switch all the way down on our variable resistor, the LED is off, the 6-volt lamp is off. But as we move the slide switch up, you can see the LED start to light. Then the 6-volt lamp comes on, and when we push it all the way up, both the LED is bright and the lamp is bright. And what's going on here is our NPN transistor is getting a small current into its base, which is this point here. This is our emitter, this is our collector. So when there's a small current that goes in from the base to the emitter, we can have a much larger, which in this case is the amplified current, going from the collector down to the emitter. So that's what we mean by an NPN amplifier. There's an amplified current going down here when there's a small current going into the base to the emitter. So that is how project 124 works. Let's move on to project 125. So here we are with project number 125. It is the PNP amplifier. There's what our circuit looks like. And there it is on the board. And with this project, we're demonstrating the amplification using the PNP transistor. In the previous project, we showed that with the NPN transistor, but with the PNP, the current that triggers the PNP is in the opposite direction. So when we look at this, when we bring out the NPN transistor from the previous project, look at the way the arrows are configured on the two transistors. On the NPN, again, we had our collector up here, our base, and our emitter. And you see the arrow goes from the base to the emitter. When you look at the PNP, our emitter is up here, then our base, and then our collector. So in this case, our current goes from the emitter to the base. So instead of going like this with the NPN, it's going like this. And that's what triggers the PNP transistor to turn on. So when I move the slide switch all the way down on our variable resistor, when the LED becomes bright, our 6-volt lamp comes on, because now the small current that's going from the emitter to the base is now creating an amplified current that is going through the emitter to the collector. And that's what turns on our 6-volt lamp. So that is how project number 125 works. So let's move on to project 126. So here we are with project number 126. It is the sucking fan. There's what our circuit looks like. And there it is on the board. And with this circuit, we're making use of our motor with our PNP transistor and our variable resistor along with a 100 ohm resistor there. Now, because it's called the sucking fan, we have the positive terminal of the motor over here, so air is pulled down through the fan. And right now, with the variable resistor all the way up here, the fan can't turn on. There's just too much resistance to overcome friction in the motor. And again, the motor still will not come on because it hasn't overcome friction yet. Once I bring this up just enough, then the fan will come on. And I can bring it all the way up to max power. And again, I can slow the fan down by adjusting the variable resistor. And get it really slow. And again, because this is also the sucking fan, if your batteries are strong enough, the fan blade will just fly up off by itself because it'll push up. So that's how Project 126 works. Let's do Project 127. So this is project number 127, and that's the blowing fan. And it essentially is the exact same circuit. All we did was just flip the motor around so the positive end is now toward our transistor. So when we power the fan up this time, it turns in the opposite direction and now it's blowing air upward. So the fan blade is not going to fly off this time because it's being pushed down against the motor. And just like before, we can adjust the speed of the motor by varying the variable resistor. So that's how project number 127 works. Let's move on to project 128. So here we are with project number 128. It is the PNP Collector. That's what our circuit looks like. And there it is on the board, and I hit the camera. Bring it back over here. Yeah. Again, it may look a little different because, again, I'm using this B6 adapter, so the circuit will look a little different, but it will perform the same thing. So essentially, what we're showing here is we've got our lamp basically in the place of our motor that we had before. So now we're going to show how our 6-volt lamp reacts with our variable resistor. So as I move this down, again, the lamp is still off, but as I come closer and closer, you can see the lamp just start to turn on. If I move it more, it gets brighter and brighter, until all the way to the end where it's at its max brightness. And again, when I adjust the variable resistor, I can change the brightness of the lamp because, again, I am adjusting the amount of current that's flowing between our emitter and collector of the PNP transistor, which again is why it's called the PNP Collector, because we've got the lamp connected to the collector side of our PNP transistor. So that is how project number 128 works. Let's move on to project 129. So here we are with project number 129, which is the PNP Emitter. And this is what our circuit looks like. And there it is on the board. Now again, this circuit is set up essentially the same as project 128 with the PNP Collector, but this time instead of our 6-volt lamp being on the collector of the transistor, it is now connected onto the emitter. So I just swapped our slide switch and 6-volt lamp around. So again, with the slide switch all the way up, the lamp is not on. But as I move it down, well, actually, it helps if I turn the circuit on. So as we move it down, our lamp turns on, and then when we get down it gets bright. But there's a catch here. If we compare the brightness of the lamp to project number 128, we'll actually notice that the lamp is not as bright as it was in project 128 when it was on the collector side. Now I don't know how much justice the camera does on that, but you can see the difference when you do the project. And the reason for this actually has to do with the 6-volt lamp being on the emitter side of our PNP transistor. Because what's happening is, see, the 6-volt lamp has built-in resistance. That's what allows it to put current in there. So the resistance that's within the 6-volt lamp is affecting the amount of current that also goes between the emitter and our base. And as we know, the base is what allows us to control the amplification of current between the emitter and collector. So if there's resistance going between the emitter and base already, then it's not going to get as much current through there as if we just had a direct connection and this on the collector end, because then that would not be affecting our base current here. So that is why our lamp is not as bright in this project as in the previous project when it was on the collector side. So that is how project number 129 works. So let's move on to project 130. So here we are with project number 130, which is the NPN Collector. There's what our circuit looks like, and there it is on the board. And in this project, it's essentially the same as project 128 with the PNP Collector, but this time we've got it set up using the NPN transistor. And as you've noted, it's on this side with the NPN transistor. So when I move our variable resistor slide switch up, see the lamp comes on and then reaches maximum brightness. And this is the same brightness as in project 128 when it was on the PNP Collector, because we have it on the NPN Collector side here, which is at the top. Our emitter, of course, on the NPN is at the bottom where the arrow is. So that shows how the lamp works on our NPN transistor on the collector side. So let's move on to project 131. So here with project number 131, which is our NPN Emitter. There's what our circuit looks like. And there it is on the board. And this time we've moved our 6-volt lamp from where it was up here on the NPN Collector down to the NPN Emitter, which is where our arrow is. So if I move our slide switch up this time, and the lamp will come on, and I move it all the way up, and the lamp is at the full intensity that it can get here. And again, the brightness of the lamp is the same as it is in project 129 with the PNP emitter. Again, it's for the exact same reason as the PNP transistor. Our lamp is on the emitter side of our transistor. And because of that, we're now factoring in the resistance of our 6-volt lamp with our base current. So again, the base current goes through here and then through the 6-volt lamp. And because of the built-in resistance that we have with the 6-volt lamp, we have a lower base current, and therefore we don't have as much amplification of the current from collector to emitter because of our 6-volt lamp being on the emitter side of our transistor. So that is how project 131 works. So let's move on to project 132. So here we are with project number 132. It is the NPN Collector motor. There's what our circuit looks like. And there it is on the board. And in this project, it's essentially the same as project number 130 with the NPN Collector using the 6-volt lamp, except this time we've replaced our 6-volt lamp with our motor and we're using it on 3 volts. So again, as I move the slide switch of our variable resistor up, again we can turn on the motor, And then if I bring the slide switch down a little bit, we can control the power of the motor and slow it down. And remember, this motor is connected on the collector side, so it is not affecting our base current. So it can get at full power when it's all the way up. So that's how Project 132 works. So let's move on to Project 133. So here is project number 133, which is the NPN Emitter motor. And like Project 131, our motor is now in place of our 6-volt lamp, and we're still on 3 volts, but again, our motor is now on the emitter side of our NPN transistor. So if you remember from how the 6-volt lamp behaves in Project 131, when it's on the emitter side, the motor is now going to affect our base current, because now we're factoring in the resistance of the motor. So again, with the slide switch all the way down, it doesn't come on until I move it all the way up, and the motor comes on. But as you can tell, if you can hear the motor, it's not running as fast as if it was on the collector side. And also, I want you to compare this to the sucking fan from Project 126, which had the fan on the collector side of the PNP transistor. So if I bring this down, you'll notice that this fan blade did not go up as high as Project 126 did. Again, that's because our motor is not running as fast as it was in Project 126, because we've got our emitter connected to our motor, which again is affecting our base current. So that is how Project 133 works. And that ends the batch of projects for this video.